Right, so today, this is going to be really short. Today, we're just talking about more functions that require the chain rule. But in particular, this time it would be functions that require the chain rule more than once. So this is just one chain rule. Yeah, so this would be like if you have a function which is maybe like 3 different functions that are composed together. Like, for example, suppose I had something like y equals the square root of sine of 3x minus 1. So this is like 3 things composed together. There's a square root function that's happening, there's a sine function that's happening, and then there's this linear function, 3x minus 1. 3 functions that are composed together. So the process and the strategy is still the same. Overall, this function is a square root function. It's the square root of something, which is something to the 1/2 power. So y prime is going to be 1/2 of that stuff to the negative 1/2 power. But then you have to do the chain rule. So it's times the derivative of the stuff that's in parentheses here. But the stuff in parentheses is sine something. So its derivative is cosine of that same stuff. But then you have to take the derivative of that stuff, 3x minus 1 times 3. So this is one where you had to do the chain rule twice, right? You had to do the chain rule once to take, well, just think of it as like you have 3 functions, all 3 things had to be differentiated. At first, you took the derivative of the 1/2 power. Then you took the derivative of cosine something. Then you took the derivative of 3x minus 1. Now you're done. So the danger here is people tend to just keep going. Like they'll say times 0 or something like that, because they'll take the derivative of 3. But we already took the derivative of 3x minus 1. You wouldn't want to do that again. You get what I'm saying? So this would be the final answer here. All right? What if I have something like y equals 5 cosine squared of 3x squared. So I'm just going to rewrite it. This would be 5 times cosine of 3x squared squared. That's really what it is. So the overall structure of this function is it's 5 times something squared. The derivative of 5 times something squared is 10 times that stuff, cosine of 3x squared. Now you're just kind of starting from the beginning, and you say, now I have to take the derivative of cosine of 3x squared. Well, what's that? That's the cosine of something. Its derivative is negative sine of something. But now you have to take the derivative of 3x squared. Well, what's that? That's 6x. Now you're done. Does that kind of make sense? Yeah. So it's really the same type of thing that we did yesterday. You just have to do it more than once. There's 2 sections to tonight's homework on Delta Math. The first section is really similar to last night's. It's just maybe a little bit more challenging, but it's still just chain rule once. And then the second section is chain rule twice. Can we do another example, or do you feel